In this video, I'm going to be explaining what a kmap is, how to use it, some mistakes that people usually make, and I'll end off with some example kmap questions. Okay, so let's start with what a kmap is. A kmap is a method. It's a method on simplifying Boolean expressions. So before you continue, you should watch my videos on truth tables, logic gates, and my logic and Boolean algebra video. Yeah. So, okay, as I was saying, yeah, a kmap is a method on how to simplify Boolean expressions. Unlike another method to simplify Boolean expressions like Boolean algebra law, using Boolean algebra laws itself, the kmap takes a more tangible visual approach. So you're actually going to be drawing um, a sort of table in when you're using kmaps to simplify, and the table that you draw will actually depend on the number of variables or the number of type of variables in the expression. For example, let's say we have this expression here, ab plus b a bar or whatever. Okay, this expression has four variables, but there are only two type of variables. So you're going to draw a kmap for this, right? And then let's say there's another expression. Let's say there's another expression, and then the expression has three variables. Okay, and then let's say it's like this. Then you're going to be drawing a different type of kmap. A kmap can have as much as four variables. I think there's a different kind of kmap for four variables, but we deal in electronics or in our syllabus, we only need to know how to draw a kmap for two variables and for three variables. Okay, so for two variables, we draw a kmap like this. We draw a box with four squares inside, and we actually draw this line coming out of it. Okay, next we draw x like on the tip, so this represents x, and then now we look at our variables. Okay, before in the question, right, they'll probably give you, oh, there's this expression a b c or whatever. What you want to do is, let's say they give you a b. Look at the order at which they give you the variables. They start with a, then they go on with b. So now you're actually going to draw your variables here in these circles, and you start at the bottom here. So we start with a, right? That means we write a here. Then next is b, right? Next is here, right? That means we write b here. Okay, next we're going to draw out some numbers, okay, or some binary. Here, this grid, we start from left to right, 0, 1. A, we're going down, top to bottom, 0, 1. And this is a kmap for two variables. You must memorize this. You must know how to write. Let's move on. Let's move on to three variables. Okay, we're still going to draw a grid, but it won't be 4 squares. It will be 8 squares. Okay, we are still going to draw this line thing. We're still going to draw x. And then now, let's say in the question, they give you a, b, c. Start with a, then we have to do out the two other variables. There are two variables remaining, and you start with b. So remember, there's supposed to be variables or variable here. We have two more variables now. It's okay. We just write bc. Then now we have to fill in the numbers. For a, it is for the vertical is actually 0, 1 remains the same. But for b and c, we're actually going to have a different set of numbers. So we're actually going to start with 0, 0. 2 zeros, then 0, 1. Then you might be thinking, oh, okay, this is counting in binary. I can do this. I watched Nikki's video. So next is 1, 0, right? Wrong! Next is 1, 1. And last is 1, 0. Why is it like this? No one knows. Only Karnov, Karnov knows. K stands for Karnov. So you must remember this order, and you have to remember how to draw this table. So you may be asking yourself, okay, Nikki, what do these numbers mean? Okay, what is the significance of these numbers? Well, do you remember how in a truth table, let's say you got A and B or whatever, 0 represents when A is 0, 1 represents when B is 1, and when you combine these, right, you get X is 1. So in this case of A is 0, B is 1, X will be 1. It is kind of the same here. Okay, when A is 0, because in this grid we actually have 0, 0. In this grid we actually have 0, 1. In this grid we have 1, 0. In this grid we have 1, 1 because we can base off using like a Cartesian coordinate system we can actually get these numbers for A and B. When A is 0, when B is 1, blank. We don't know. When A is 0, B is 0, it will be what is supposed to be here. So in a filled kmap, you probably have numbers here. And let's say in this example, now we know when A is 0, when B is 0, X is 1. That's how you read a kmap, okay? But in most questions, they're gonna ask you to fill it up. Oh no! I don't know how to fill it up. Now I will die. No, it's not true. Okay? We're gonna walk through this. When they give you an expression, or when you create an expression, listen to me, you will have ended things, and then you have a plus, then you have ended things. Now listen very closely. In this expression, these sub-expressions that are combined together with pluses, they are equals to 1. They are equals to 1 when x is 1. Meaning, in order for x to be 1, is a rule, or you must know, in order for x to be 1, both this ended AB and this ended A bar B must either be 1. Why either? Because of the plus. That is the rule. When x is 1, either any expression or at least one of these ended expressions in your full Boolean expression, they must, at least one must be equals to 1. This is a concept that you must understand. Okay, what's the point of knowing this? That's a bit weird. Okay, stay with me. I'm gonna explain something further, which will fully fully draw out the picture for you. So let's go into a bit more depth. Okay, you say that either one of these expressions have to be 1. So okay, let's say AB is 1 lah. AB is 1. So in this case, x is 1 already. Okay, woohoo! But what are the values of A and B? Nikki, that's impossible. There are two unknowns. We can't find this out. No, that's not true. We can. A times B equals to 1. We already know what's A and B. How? Okay, remember how the variable A, the variable B, they can only have two values, 0 and 1. So let's write out every single possible combination. 0 times 0, 0 times 1, 1 times 0, 1 times 1. Okay. So what are these values? 0, 0, 0, 1. There's only one case where A times B is 1. And that case is when A is 1 and B is 1. So we already know that A has to be 1. B has to be 1. As such, when AB is 1, we know A is 1, B is 1. Okay. Nikki, you bluff me one. You bluff me. Because this is a very specific case. What about other expressions? What about B, A bar? Okay, let's say this is 1. So X is 1, yeah? We already know. But Nikki, then the others one cannot. You cannot find out whether B is 1 or A is 0 or whatever. We can. Let's write out all the possible cases again. All the possible cases is 0, is like this. Okay, this is AB, or BA rather. But there's actually a bar here. So let's have a version here, A bar, and then we'll get this. Okay. So basically, what we have are all the possible cases. All the possible cases is like this. So what are the values? Again, we're looking for 1. What are the values? Only one case that is equals to 1. All the other cases are 0. That means we already know B must be 1. A bar must be 1. So in every ended expression together that's equals to 1, you already know all the values. In this expression, let's say we have this let's say we have this ginormous expression if it's equals to 1 we already know all the values. Okay, I won't show you the method on how to get a large expression like this, because now the only way you know is you have to write out all the cases, right? But from this, I already know A is 1, B is 0, C is 1, D is 0, E is 0. Yeah, I already know that those are the values. This is equals to 0. This is equals to 0, but because it's you don't forget the bar. B is 0, but when you bar 0 is 1. And that is the method to get what the values of A and B are, or of A and B and C are. When you have an expression, let's say we have this A, B bar, C bar equals 1. To get the actual raw values of A, B, and C, we do the following. If there is no bar, A has no bar, A is 1. If there is a bar, B is barred, then B is 0. Then we can do the same thing here. C has a bar, so C is 0. Again, when it's equals to 1. Don't believe me, this works out. B is 0, then don't forget the bar, 1 times 1 times 1 equals 1. Correct. So that is how to get when you have an ended expression equals to 1, you can get the values of all the variables. Okay, but how does this help me in any way in understanding kmap? Very, very simple. Basically, we want to fill up this kmap here. To start, the first step into filling a kmap is you ask yourself, what cases are x equals to 1? Aha! This is where everything you've learned will help you. The cases of when x is equals to 1 is when A times B and when B times A bar. But you need to know what the values of A and B are. Aha! We can use exactly what we just learned. In order for A times B equals to 1, A must be 1, B must be 1. So we go back to the kmap, we see, A must be 1, here, okay. Oh, B must be, okay, here. This is when x is 1. Then we move on. That's not the only possible case when x is 1. B, A bar can be 1 as well. Okay, what are the values of B? What is the value of what A? We use the rule we just learned. When you see B, again, ended expression equals to 1, this specific case, when we see B no bar, then B is 1. When we see A got bar, it is 0. So, we know B has to be 1, A has to be 0. So we get this. And since we don't have any expressions that show and since these are all the expressions, and these expressions represent when x is 1, therefore, we can just use the signs of deduction. The rest are 0. And this is the filled up kmap. This is the filled up kmap for this expression. Let's move on. Let's say, oh yeah, this is wrong. That should be D. Now we have this much larger, much larger expression. But the process is exactly the same. We got A, B, C here, and we already know that for D to be equals to 1, either this or this has to be 1. And we actually already know what the values are when they're equals to 1, when they're ended together. Remember, got no bar equals 1, got no bar equals 1, got bar equals 0. Do the same thing here. And with these values, we can actually point exactly which square it should be on the kmap. A is 0, A is 1, oh okay, A is 1, A is 1. B is 0, B is 1, sorry. Oh okay, then B must be here. Then C is 0. Oh, then it's here. A 1, B 1, C 0, here. That's it. We can do the same for this one. A bar, A is 0, oh okay, A is 0. B is 1, oh okay, B is 1. C is 0, oh okay, C is 0. That's it. A is 0, B is 1, C is 0. That's it. And again, signs of deduction, the rest will be 0. And you fill up your kmap already. That's it. That is how to fill up a kmap. Okay, I know how to fill up a kmap now, but how does this actually simplify things? We move on to step 2. Okay, we're going to do something called grouping. So, what do I mean by grouping? We're going to look at our kmap, and we're going to group ones together. Okay, so you can see, you can say now, oh okay, very simple. Oh, group the ones together, right? Okay, so 1 1 here, 1 1 here. I'm done. Yeah, that's pretty much it. When you group, be sure to circle. Be sure to circle, and then you group the ones together, right? It's like this. So that's it, right? Wrong. There are a few rules that you need to know. Okay. First of all, you can only group in groups of 1, 2, 4, and 8. What do I mean? What do I mean? Let's say we have this. Can you group all these 3 ones together? Can you? No, you can't. Because it goes against the rule. Remember, you can only group in groups of 1, 2, 4, and 8. Oh, okay. So can I group like this? Cause it's all 4, right? 4. So I group. Yes, you can. So 4. Oh, okay. Can I group like this? Cause it's 4. Oh yeah, can. Oh, okay. So got 4 like this. So can I group like this? Wrong. You cannot. Next, I'll talk about the laws of grouping. When you group things together, other than you must remember that you must group in groups of 1, 2, 4, and 8, you must also understand that you cannot group diagonally. You can't. This is not allowed. You cannot group diagonally. So, you cannot do something like this. This would be like this. Okay? You cannot group diagonally. And there's one more rule you need to know. How would you group this? You'd say, oh, okay, I will group it like this because they're not combined, so I can't group them together. And I can only group in groups of 1, 2, 4, and 8. Okay, so they're one each, so should be fine, right? Yes, that's true. But you can also group them like this. What does this mean? I'm actually putting them in a group together. In kmaps, you can group across dimensions. So you can actually imagine the kmap is folded in on itself. This is here. And you can imagine that this is here. Because you can actually group like this. You can as well. So, okay, I can group the ones together. What's the point of doing that? The point is with the groups, you can actually with the groups, you can actually form a simplified expression. But in order to get a simplified expression, you actually need to group you need to group the ones in a way such that there are the least number of groups in the kmap. For example, we have this kmap here with this group of ones, and there's a few ways we can group them. We can group them by grouping all four together. We can group them by separating them into twos, or we can just group them like this individually. So we have so much variety in grouping, right? How do we know which group is right? You know the group is right when once you're done, you have the least possible number of groups there. So when you're done, you should have only the least number of groups. So in this case, you actually can only have one possible group, or your least number of groups is 1. Because in the big picture, right, there's only one group here, and that's the least number of groups, yeah, because that's the biggest you can do. So in the end, you must only have, in this case, since you can group it as 1, you must group it as 1 because it's the least number of groups. It's the least number of groups. So let's do another exercise actually. Can you tell me what is the best way, or can you try for yourself? Can you try and group this? So you can pause now and try. So there are a few ways you can group this, or 2 ways actually. You can group it like this, and you can group it like this. The last way I showed you, the way in blue, that is the correct way. Why? Because when you group with purple, you have 3 groups. When you do the blue group, you have 2. So you have to first, before we talk about how the groups even create the expressions, you must create the least number of groups. You must understand this. Okay, so now I'm going to finally go into how does a kmap with the groups actually help us simplify. So to simplify a kmap, we actually look at each group, because in your kmap you may have one group, you may have a few groups. So to start simplification, we look at each group first. So in this, right, we look at this group. Then we ask ourselves, what cases is this group 1? Because in this entire group, the group will be 1. But what cases is this group 1? So, okay, the cases would be, we will have to look back at the variables, right? So A would have to be 0, B would have to be 1, C would have to be 0. So A would have to be 0, B would have to be 1, and C would have to be 0. Next, you look at this case, you ask ourselves, okay, this is equals to 1, right? But we need to convert this in such a way such that it represents the original expression. Because remember, we took this and we converted it into a way, sorry, or actually we took this and then we realized that it was 0, 1, and 0. So we need to do the reverse now. We have to do it back. So what we do, the rule, is that when you see that the variable is 0, then A would be barred. When you see B is 1, right, then there'll be no bar. When you see C is 0, then there'll be a bar. So when that variable is equals to 0, its original variable, right, would be barred. And we can see that's actually correct. Next, we look at the other case. In this case, I'm just going to do it quickly in my head. It is actually this. Is equals to 1. So now we need to use a bit of pattern recognition. Let's look at these two expressions and ask ourselves, what is common? What is common is actually B is the same, C is the same, C bar, because it's both C bar, but A fluctuates. A is sometimes not bars, A is sometimes bar. So we can conclude and the value of A changes, but notice that the output the D the value D is still 1. What does this mean? This means that A is useless. No matter what A does, even if A is 1, even if A is 0, the output remains unaffected. The output is still 1. A contributes nothing. We kill A. So we look at each group. Then we see, oh, A is useless. We kill A. What do we have left? We have what was common. B, C bar. We write that down. And this is the simplified version. That's it. So all we need to do is when we group things together, we see what is useless or what fluctuates, what changes. Then we kill that, we write down, and we write down what is remaining. So let's do one example, then I'll be done, because I've actually stretched this out a long way. Let's say we have this kmap. My task for you is group them together and get the simplified expression. Okay. Oh yeah, and pause the video, yeah. But okay, alright. So we start by grouping. Okay. So in this we have a few ways of grouping. But I will group it like this. And this produces the least number of groups. There is actually another way that we can group this, which is like this. We can group like this, and then we wrap around. But again, right, there are no benefits since the number of groups actually remains the same in either yellow or green. Yeah. So let's. I'm going to use yellow. And then remember the next step, we need to look at each individual group. So let's look at this group first. In this case, in this group, there's only one case when D is 1. Okay? And that is A has to be 1, B has to be 0, C has to be 0. Let's look at this case now. Let's look at this case. In this case, we can visually see that A is fluctuating between 0 and 1, and we can see that in both cases, regardless of what A is, the case it is still 1. So we know that A is useless, we kill A. Then we just write down what the expression should be for B and C. Remember, when B is 0, we bar. When C is 1, we don't bar. That's it. Now let's look at this last group. Again, A is fluctuating between 1 and 0, not affecting any of the cases, kill A. And then we write down what B and C should be, which is this. And that is it. That is that is that is the answer to this and that is how kmaps work. That is the rules for kmaps. That is how to group, and that's how to simplify. So yeah, that's it.